This video is a continuation of a previous video that talks about how to find the mean and standard deviation given a set of data. And we talked about Timbits. We showed how to find the average number of Timbits sold, which was 15, and the standard deviation of 4 Timbits using our graphing calculator. And then we even drew the standard normal curve, labeled 3 standard deviations above and 3 standard deviations below to represent the normal distribution of this data. We're going to continue by using this information, and we're going to say, based on this data, determine the probability that the next customer will buy less than 10 Timbits. So I'm just going to remind ourselves here that the average was 15 Timbits with a standard deviation of 4 Timbits. Now it's a good idea to represent this as a bell curve just to give yourself a visual. So here is a small bell curve. Here down the average, it's 15 Timbits. And this question's asking you about 10 Timbits. So 10 is located somewhere down here. Here's 10 Timbits. And it's asking you that they will, what's the probability of the order less than that? So we're talking about this shaded bit of information. Now, two things that we mentioned in class when we talked about these is that when we're reading bell curves, we're always reading from left to right. So we're going to be actually concerned with the data that's from here to here. Our upper limit is 10 Timbits. Our lower limit we'll talk about here in a second. Now, to use this information, we have to transfer it into a z-score. A z-score is given by this formula, provided on your formula sheet always. A z-score is just an indication of how far away a piece of information is from the average measured in standard deviations. So a negative z-score means we're below the average, which this 10 is below the average. We should come up with a negative z-score. A positive z-score means we're above the average. So if we continue this out, a z-score of 10 Timbits, x is the number we're talking about, would be calculated by 10 minus the average, which is 15, all over the standard deviation, which is 4. So this z-score, when we calculate in our calculator, turns out to be negative 1.25. So that means 10 Timbits is actually 1 standard deviation, actually 1 1/4 standard deviations below the average. Now, we talked about how we address this lower limit, this less than part right here. Now, another thing we talked about in class is that beyond 4 standard deviations and even 5 above the mean and below the mean, hardly any data lies. It's improbable that information would be out there based on the normal distribution. So we say our lower limit here, if this is a negative 1.25, if I went to negative 99, that means I'm well beyond the negative 5 lower limit of standard deviations. So the next thing now that we looked at, to calculate this on our calculator, we went to distribution, which is right above the vars button. So if we go above that vars button and you go second function vars, we used normal CDF. So we're going to do normal CDF. And when we use normal CDF, we always talk about the lower limit moving up to the upper limit. Now, depending on how new your calculator is, you could see 2 different versions here. So I'm going to go down to normal CDF and I'm going to choose enter. Mine has the older software. If you have newer software, it actually says lower, upper, and then a few more options and a paste. You just enter the information the same as we're doing it here. So here's my normal CDF. If I look back on this bell curve, we're saying we need to start at negative 99 and go all the way up to negative 1.25 to get this shaded region on the bell curve. So my work simply would be to write normal CDF, the lower limit, negative 99, all the way up to the upper limit, which was negative 1.25 for reading left to right. So in my calculator, if I put those in, negative 99, above the 7 is a comma. Whoops. We choose that up to negative 1.25. Close the bracket and now hit enter. And those with the newer software, you can hit paste. we could see right here that we have 0.1056, which is roughly 10.56% chance. So the answer to this question is 10.56% chance they'll order less than 10 Timbits. So we're using our information or our knowledge of Z-scores to estimate or predict what the next customer would have. So there's one type of question that we could ask you. Moving on to the next question, I'm going to just keep this information fresh that we have an average of 15, a standard deviation of 4, saying what is the probability the next customer will buy more than 12 Timbits? So again, we're going to start with a nice little sketch of the bell curve to give ourselves a visual. Here's the average of 15. 12 is somewhere here. Now it's saying ordering more than that. So we're talking about this shaded region way up here. So we know that our answer should be more than 50%. So we need to convert our 12 into a Z-score again. Z-score formula, again from your formula sheet, is x minus the average over the standard deviation. X is the number we're trying to determine, so that's the 12, minus the average all over the standard deviation. And if we calculate that number, we get a negative 0.75. So that means this, as a Z-score, is negative 0.75. We know it should be negative because it's below the average. And we want to calculate all the way up here, reading left to right. So this goes right to the end of the bell curve, and we said beyond 5 there's nothing. So our upper limit, we just use a positive 99 this time. So again, for our work, it's normal CDF, and we put reading left to right our lower limit, which is negative 0.75, all the way up to our upper limit, which we're going to say is 99. So if we go back to second function, vars, choose number 2, which is normal CDF, put in our information, negative 0.75, comma, 99, close the bracket, hit enter. Now we have about a 77.34% chance of this happening. So our answer, 77.34% chance the next person will order more than 12 Timbits. So this was an example of ordering more than a number. There's only one other type of question that we can ask you right now about bell curves. So here's the next one. Based on this same data that we talked about, what's the probability the next customer will buy between 15 and 20 Timbits? So I'm just going to, again, include this information. And we're going to start with a sketch. So my average is down the middle. That's 15. And that's one of the numbers I'm talking about right there. And we're going up now to somewhere to 20 Timbits. So we're saying what is the probability that they'll order between 15 and 20 Timbits based on the information we have. So we need to read left to right again. We need to go from 15 now to 20. So this is going to require us to use the Z-score formula twice. First, we want to figure out that lower limit of the 15. So 15 minus 15 over 4. This should give us a Z-score. 15 minus 15 is 0. 0 over anything is just 0. Now remember, we said earlier in the video that a Z-score tells you how far away you are from the average. Well, if you are the average, the Z-score has to be 0. So 15 has a Z-score of 0. The upper limit is 20. So we're going to start by saying 20 minus 15 all over 4, which 20 minus 15 is 5. Divided by 4, that's a positive 1.25. And again, it should be positive because it's above the average. So looking at my bell curve, that means this is a z-score of 0, going up to a z-score now of 1.25, reading left to right. So for our work, we just say to find this information on our calculator, that's a normal CDF situation again. Reading left to right, we're starting at 0 on the left for our shading, going all the way up to 1.25. So in our calculator again, second function vars, number 2 is normal CDF, and we go from 0, comma, 1.25, close it, and we get about 39.44%. So there's a 39.44% that the next order will be between 15 and 20 Timbits. So those are the three types of questions that we can actually look at in math using z-scores and normal distribution. We could take just one more step with this and saying, okay, based on this data, if 4,000 more people came to Tim Hortons this day, how many people would you expect to order between 15 and 20 Timbits? Well, we just established that about 39.44% of them will order between 15 and 20. So if we take the 4,000 and multiply it by 0.3944, which is that percentage as a decimal, this should tell us how many of those 4,000 people will actually order between 15 and 20 Timbits. And if you crunch those numbers, it turns out to be approximately 1,578 people or customers that the next time through, if there was 4,000 of them, would order between 15 and 20 Timbits. So that's using our information of z-scores, translating that into some probability under the standard normal curve.